Okay, so we're given this right triangle here, and we're asked to determine the 6 trig ratios for angle B, which is right here. And looking at this triangle, we know that the opposite side of angle B would be 8, and adjacent to B would be 15, and the hypotenuse is 17. So starting off with sine of B is equal to, we know that sine is opposite over hypotenuse from SO and SOHCAHTOA. So sine of B is equal to 8 over 17 because opposite over hypotenuse. And then for cosine, we know that cosine is adjacent over hypotenuse from CH and SOHCAHTOA. So adjacent of B, which is 15, over hypotenuse, which is 17. So cosine of B is equal to 15 over 17. And the next one is tangent. And we know that tangent is opposite over adjacent from TOA. And that would be 8 over 15 because 8 is opposite, 15 is adjacent. So the next three trig functions are very similar, but the only difference is that they are the reciprocal of these trig functions over here. So let's see, cosecant would be the reciprocal of sine, which is opposite over hypotenuse, so the reciprocal would be hypotenuse over opposite, and that gives us 17 over 8 if we look here. And then secant of B is just the reciprocal of cosine, which is adjacent over hypotenuse, so the reciprocal of that is hypotenuse over adjacent, and that is 17 over 15, as we see here. So secant of B is equal to 17 over 15. And that'd be the same thing for cotangent. Cotangent is the reciprocal of tangent, which is opposite over adjacent. So cotangent of B is adjacent over opposite, and that's 15 over 8, and we see adjacent over opposite. And if you look at the ratios of these trig functions here, you see that they're just the same thing here, but just flipped, and the reciprocal. So that's how we find the reciprocal of the trig ratios.